So here we're told that the function f is defined as f of x is equal to 5x squared minus 20x plus 2, and we're asked to use calculus to find the coordinates of the local minimum point of f. And so there's going to be kind of a test of knowledge on how to find either maximums or minimums depending on the circumstances. And so if we just have a quick look at f of x here, we can see that it's a quadratic function, and so that means it's going to fall into kind of one of two categories. So if we have sort of two sets of axes, very roughly drawn axes, but our quadratic is always going to either be facing down like that or facing up. And so if it is facing down, so the kind of the sort of end point is kind of facing down this way, this is going to be any quadratic with a positive number in front of x squared. So it's going to be having, like in this case, like it's a 5x squared, that's going to look like a sort of U-shaped quadratic. And if it was negative, it would be an M-shaped quadratic, or an N-shaped quadratic, I should say. And the reason I'm kind of bringing that up is because we should always know whether we're looking for a maximum or a minimum. In this case, they actually tell us we're looking for a minimum, and a quadratic only has one turning point, so that's usually going to be grand. But if they were to give us a cubic and ask us to find the minimum, we need to make sure that we're sort of finding the minimum rather than the maximum. And so that's kind of why I would always take a look at the function before I differentiate it. But now that we've done that, we can actually just find the minimum by differentiating it and set it equal to 0. So we're going to set f dash x is equal to 0, and then also differentiate it. So we can just do that using the rule in our log tables, which is that for any term x to the n in a polynomial, it becomes nx to the n minus 1. So we essentially bring down the power and then reduce the power up on top by 1. So doing that for f of x, we can see we've got 5x squared, which is going to become 5 times 2, which is our exponent, and then that's going to become x to the power of 1. Our minus 20 is going to be minus 20 times 1, which is the exponent, and then x goes to x to the 0. And you kind of see where this is going, because for the 2, that is just going to disappear because the 0 comes down in front, the 0 being the power of x for just the number 2, and that's going to just disappear. And so we're left with this equation here, which is that 10x minus 20 is equal to 0 because we said f dash x is equal to 0. And so to find the minimum, we can simply add across by 20 first. So that is going to give us 10x is equal to 20, and then dividing across by 10, we get that x is equal to 20 divided by 10, which is going to be equal to 2. So x is equal to 2. And so the very last step in this is going to be to find the other coordinate, so the y coordinate for our point of f, which is the minimum. And to find that, we can simply plug in our x value for the minimum, which we've now found to be 2, back into our original function, and we can find out what the y coordinate of our minimum is going to be. And we're going to find that when we do that, we get out the point minus 18. So our point then is going to be the x coordinate and the y coordinate together. So that is going to be the point 2 minus 18, and that's going to be it for this question.